Isentio, we save lives and suffering and healthcare costs. Our cloud platform can identify bacteria more accurately, much faster, and at a lower cost than any current methods. But why is this important? Because the leading cause of death among children and elderly is bacteria infections. It's not cancer, it's not diabetes or heart attack, or any of the other headline causes. It's actually bacteria infections. And broad-spectrum antibiotic, that's a typical solution in these cases, but that adds to the side effects, the hospital stay, and it also increased the healthcare costs. Broad-spectrum antibiotic also add to the number of resistant bacteria. I'm sure you heard about the superbugs, which actually rated #1 healthcare threat by CDC in 2014. And did you know that 1 out of 20 people going into the hospital acquire a new bacteria infection while they're there? This is so-called bacteria that hospital-acquired infections. And 100,000 dies from this every year, only in the US. The rest, they stay 5 to 6 days extra in the hospital. That's a huge cost for the patient, for the family, and for the healthcare system. And I know this pain personally. I was hospitalized for appendicitis 15 years ago. It was a routine surgery, it's not dangerous. But in the middle of the night, I had really trouble breathing. The next thing I remember was waking up in the intensive care. 4 days later, I had been in a coma, and I had acquired sepsis at the hospital. I had had 25% chance of dying, 25% chance of permanent side effects, and I was so happy I was among the 50%. And then 3 weeks later, I could actually go home, and I was so happy to be alive. However, if this was a child or an elderly or somebody with a weak immune system, this story probably wouldn't have that happy ending. But what is the problem with this? Today, we identify bacteria with lab cultivation. You go to the doctor, he takes a sample of you, looks at you, sends the sample to the lab, but you don't expect any answer back before several days. So if you're really sick, he just give you broad-spectrum antibiotic, send you home, and hope that you get well. In the lab, they try to grow it, but it fails in 1/3 of the times, because the fallback solution is broad-spectrum antibiotic. Because if the patient got broad-spectrum antibiotic before they took the sample, it's not possible to grow it. There is a better technology out there, and it's DNA technology. It's very good. The hardware is already there in all the labs and hospitals worldwide. But it's so complex that it's not used for clinical diagnostic. It's only used for research. Using DNA technology to identify the bacteria will take the time down from days to hours. And it takes the failure rate from 1/3 or 30% down to 10%. That's really good. However, there are so many disadvantages leading to high cost for the healthcare provider and the end user. So it's not used where the speed and accuracy really is a matter of life and death. So, what did we do? Yes, we had a solution for this. And we make DNA testing usable in a clinical diagnostic setting. We have a software as a service, and it worked with all the current technology that's out there, and it also worked with the future platforms. And we can read pure sample and complex samples, and together with our proprietary database, we take the failure rate down from 10% down to less than 1%. And the cool thing is that any lab technician can use our software just with a few hours of training. And we add traceability to the process. So, just to mention, there are a lot of things going on in clinical diagnostic, and there are some new technology coming to the market pretty soon called next generation sequencing. We have a solution for that too. And the big problem with the next generation sequencing is that the data storage is really a challenge. You get really in-depth analysis, but you will have weeks of sorting through the complex data. We take it down to minutes. So, a bit short about our team. Everything started when our Øystein Kommedal, our microbiologist, he was in his lab doing work on the current technology, and he ran a sample that was not possible to interpret it. So, but he could see some patterns there. So he took this file to his friend Bjarte Karlsen, and together with Øystein, they said, yeah, we'll find a solution for this. We'll probably use like 2 weeks or something. 2 years later, they had a solution. It's called RIPSeq. It's really the only current method that can read complex samples still, yet. So now we are based here in the US. We had added a really talented team to our company that are really specialists in both clinical diagnostic in Europe and in the US, and also know a lot about the customers, the vendors, the partners, and also regulatories. You know, that's of course some of the needs. And we do have customers. We have a lot of them. We have 60 customers worldwide. You probably know some of them. Mayo Clinic, CDC, Stanford, our laboratory, Karolinska. And they love us, and they tell us, and that's really cool. When we have trained our laboratories, 20-something lab technicians, they wrote us back saying, we have hit the Valhalla of sequencing. And that's even cooler when you're from the Nordic region. So, and Mayo Clinic, they actually wrote an official paper stating that they saved 5 days on complex sample using our methods. We didn't even know that they were writing the paper, so that was really cool. We have 18 articles and posters that confirm our method. Half of them are written by our team, the other half from completely different people that we don't know about. So I probably know that the time is running out, so I will not go into the market, and we will jump through the financial projections. We know that there are big growth here, and as the previous speaker said, that's what we're looking for. We need that extra kick when we are a startup. So the growth is there. And I just want to mention that this is to sell the solution, the software solution, to the labs. It's kind of the beginning, because our big vision is that we will collect that data and make it available for the greater goods. And we also want to add a social layer to that, so that the researchers worldwide can do research on this and figure out better medication, more direct to what's wrong, and we can monitorize outbreaks and do research with this. So that's the future.
All right.